Hello guys! This is the continuation of our tutorial in Murphree efficiency. We already know how to program the McCabe-Thiele method using Excel. Today, we're going to modify this program to incorporate the Murphree efficiency and to find the actual number of stages. To start with, we're going to run through this program first. In most problems, the usual given are the following: distillate liquid mole fraction XD, feed liquid mole fraction XF, liquid mole fraction at the bottom XW, and the Murphree efficiency. To obtain R mean, you can use this flow, or the simpler way, wherein you equate the equation of the Q line and the equation from the XD to the pinch point. Notice that we have a conditional statement because we didn't converge the bottom and the top sections. Instead, we started from the top and continuously proceeds until it reaches the bottom section, as shown in the graph with green lines. This if condition is useful when we cross from rectifying to stripping line. So that's all for the McCabe-Thiele method. Next, we will incorporate the Murphree efficiency in our Excel. Given the Murphree efficiency, we can graph the actual curve. XE is the same as the X values used in the ideal equilibrium curve. So the values given for XE are from the equilibrium curve here and from the given equilibrium curve in the problem. As per given XE values, we can calculate for the YE with this equation. Then for the values of Y, we use an if conditional statement. If the X value of the equilibrium data is less than or equal to the X coordinate of the intersection of the rectifying line and the stripping line, the vertical line will fall on the rectifying line. And if it is greater than, it will fall on the stripping line. The X coordinate can be seen here. This goes all throughout the stages. After getting all the values of Y, we can now proceed to the calculation for the values of YE prime, as per given in the formula here. Taking the values of XE and YE prime, we can now graph the equilibrium curve for the actual process. Shown in the diagram, the actual curve is in purple dashed line. In getting the coordinates of the different stages, we can also use the process used in the McCabe-Thiele method. As we can see here, there is also an if statement. Same goes like in the ideal, which is the main purpose, is to have a continuous graph. This time, starting from the bottom to the top to avoid overlapping of lines for aesthetic purposes. The blue dashed lines represent the actual stages. Finally, we can now count the number of stages. For a DL process, the number of stages is 1, 2, 3, 4, and 5. For this part, round up to 5. For the actual process, the number of stages is 1, 2, 3, 4, 5, and 6. This final stage is also a rounded value of 6. So that's all for this episode. In the next episode, we will solve a sample problem. So tune up for more updates.